Hey everybody. So this particular research paper is called A Unified Geometric Space Bridging AI Models and the Brain. And it's put out by a multitude of institutions. A majority of them are China-based, although the last two are Department of Biomedical Engineering out of New Jersey Institute of Technology and School of Computing from University of Georgia in Athens, Georgia. And then so this paper overall, uh, it's the first paper that I've seen where they take my research in these areas and like they do it two steps further. Like I've literally never seen a research paper do that. Right? Like my research is generally in areas where most people aren't looking overall. Right, which is why I tend to focus on those areas. But with this paper, it's very specifically and very clearly, and what they talk about are these concepts in a way that I have specifically avoided talking about them in, right? So, like, I talk about geometric projections and the latent space, and then what that latent space is and means directly and specifically for the model, right? And I always frame it very specifically in and around that. The best way to talk about what this research paper's claim is the bottom, the last like few paragraphs of the introduction here, and then so uh, essentially, to overcome this barrier, we introduce the groundbreaking concept of brain-like space, a unified geometric space that allows any AI model to be situated and compared on a common ground. Instead of relying on stimulus response alignment, this space is defined by the intrinsic topology of the organization. Using graph-theoretic similarity measures, we map the spatial attention of patterns of each model onto canonical human functional brain networks derived from resting state functional MRIs. Thus, every model from language, vision to multimodal is positioned within a continuous landscape that reflects its degree of similarity to the intrinsic functional architecture of the brain. This approach reframes brain AI alignment as a problem of organization, not input. Our extensive analysis of 151 transformer based models spanning state of the art LVMs, LLMs, and LMMs unveil an arc shaped geometry within this space, reflecting a gradual increase of brain likeness depicted as overall organizational similarity to functional brain networks. Crucially, different models exhibit distinct distribution patterns within the arced shaped geometry associated with different degrees of brain likeness, shaped not only by the model modality, but also by whether the pre training paradigm emphasizes a global semantic abstraction, as well as whether the positional encoding scheme of a model architectural design facilitates deep fusion across different modalities. The degree of brain likeness for a model and its downstream task performance might not necessarily be identical twins. We'll leave it there, right? But so, and then they go into and they have a lot of images and diagrams and proof and like what this what they call the brain structure, what I call like the uh, latent space within the model looks like, right? And then it's this same structure across different modalities is what they highlight, right? And I've seen these structures a lot. Um, these exact like types of structures and images when it comes to the models overall. But this paper is taking it that next step, right, and saying that essentially this geometric projection, this latent space, is like essentially and exactly what the brain does, in that it's that the um, geometric projection and your brain projection is essentially like they're comparable. Like P equals MP is essentially what this paper goes into deeply overall, right? And then so uh, to me, like I very like I guess the next thing to point out and to state very specifically within that and within this paper is that they do, and I want to highlight it, that they do uh, make this claim and they back it up mathematically, right? And you go down to the past the conclusion and then to the appendix of the paper here, they lay out all of their methods. Their method are mathematically based. They give algorithms. Uh, they give, here's the construction of the spatial attention graphs, etc. Right. So like this isn't like a philosophy based paper. It's not like a manifesto. The big thing, like, so all like there's a whole bunch of institutions attached to this, right? And then like the big thing with uh, any paper that comes out of China overall is that like it's basically like peer reviewed before it comes out, right? That's why I like read that type of research overall, because it's like you're guaranteed that it's not a manifesto. Like um, this is heavily researched, heavily scrutinized, and then when it comes out, especially with these many institutions attached to it, it's essentially like the CCP putting their stamp on that, right? And then so this is essentially like um, research that is 100% in line with what the government within China wants and to be researched, and then as well as what they want to be published around that, right? And then so this is very specifically what they are researching and talking about, and their framing of it overall. And then so overall, I think that's an important distinction and an important point to make, right? Overall, like so, if this paper and this video that you're watching here were being made in China, like all of the hedging around this concept, basically calling it exactly what it is, right? Uh, that I'm doing within this video wouldn't be necessary and wouldn't be viewed the same, right? So it's a like our shaping and understanding of these models overall is very culturally driven, uh, as proven by that, right? And then in Western culture overall, like this, like exactly what this research paper is saying is very stigmatized overall. Like I feel like it's the best way to put it. But uh, to me, I think that this research paper overall allows me to talk about a few aspects of this that I frankly I've never talked about, right? And then so like, um, well, when I went to university, the thing that I studied was rhetoric. Like that's like and so surprise, right? Uh, Rhetoric plays a huge part overall within my life, but uh, within rhetoric, it's essentially the study of how people work overall, right? And then the biggest thing, and I can say this like from like every like my the very second that I started diving into the subject, it was something that like has haunted me, and from that day forward is that humans, how they work, like how the brain works, is a very mechanical process. Like very mechanical. Like it can be hacked. People can be hacked. Like the more that you study into the fields of psychology, rhetoric, communication, all of like the intersection of all of those fields, and this was like 20 years ago, right? The framing was, and the framing has been, and starting from like the 1950s, 1960s, that humans are very mechanical, and it's scary overall, right? Um, and a lot of the study of rhetoric is around those areas, right? Like understanding, dissecting how humans can be hacked. Like the why has been um, kind of a big question within that, right? A lot of people, there's no clear answer around that, but these are known things overall, right? And then so just uh, that whole research area overall has kind of fascinated me my whole adult life. And then to me, there's another aspect of this that I think about overall when I think about this particular subject, and it's another area that I've never talked about on this channel, which is like neuroplasticity, right? And then neuroplasticity overall is a concept that I very first heard about as a child. And then I don't know if neuroplasticity is correct or true. Like I can't prove it outright. Uh, it's more and more proven now. But when I very first heard of the concept, my first thought around it was, well, not my very first, but my early thoughts around it were, okay, if this concept is true, like how exactly would you utilize it, build it out, etc. Right? And then I've thought like about that question a lot throughout my life, and then I've also studied philosophy extensively throughout my life, right? And then so all these concepts that they come together, and then throughout my study of philosophy and thinking around those things, I really got into Kant for a long time. Like really fascinated by Kant. Kant, like how his framework overall, it's like very hard to disprove. Makes a lot of sense. Like I think Kant overall just uh, made a lot of sense in general. But one of his big concepts that he talks about is the concept of the rose-colored glasses, right? That everyone sees the world through glasses that are rose tinted, and but your individual lens is your individual lens. And then further from there, I like another philosopher that I came to really admire and study a lot was Gilles Deleuze. And then Deleuze has a lot of like more interesting philosophies, and but his whole entire concept and a lot of his philosophy overall is applying those weird and more abstract philosophies to like real world principles, and actually like applying philosophy like in your life, right? And around those things. And then so within that, and to me, like just bridging those two things, I worked on this concept in my mind for a long time of uh, so Kant's rose-colored glasses and your rose-tinted glasses are essentially like your OS, right? And then like if I were to think of Kant in 21st century terms, that's kind of more how I would think of Kant, where uh, my glasses are the OS that is individual to me that I see the world through, and then so like what is like what makes the color rose in those glasses is like the next question that I ask myself within that. And then to me, the base that I came to like a long time ago is that essentially like the base OS of a human, if you will, is logic. And then so uh, every single person has rose tinted glasses and rose colored glasses, and we all have these glasses on, and these glasses represent us through our experiences, and they're shaped and tinted differently, and they tint differently based off of our experiences and knowledge, etc. But we all have the same base OS, like it's the same base operating system that is running these glasses. Right? And then so within that, and then taking like the next step within like Deleuzian philosophy, kind of to me, the next step approach within that was, and my thinking was like, what would be a different OS? Like, what if I was able to switch out those rose tinted glasses for like that base of it, like the base OS, and then put in a different base OS? What would that look like? What would that be? And I pondered that for a long time, and then I came to the conclusion that a different OS would be probabilistic based, like probability based, right? Like not you could apply logic to it, and it would you could see the logical steps and progression, but it's not a um, OS that's purely based on logic. Like the base of the OS is more probability, and then so like what does that look like in real world terms, right? And then so overall within that, and then combining those things, kind of what I got like really good at overall, is like being able to read people, right? Like body language, uh, those types of things overall, right? Like I mean, just throwing it out exactly for what it is. Like I know 100%, like it's like a scientific equation. If you talk to me, like, or whoever, you talk to a pretty girl, you make eye contact with them, they immediately look down, their eyes dart down immediately, and then they crack a small smile that is like just the most primitive base form of human attraction, right? Overall, and that's just I can read that via pure body language signals, and then that can be translated into the base OS of a human, which would be logic. But uh, the actual like base mechanism within that is probability, and then more probability based. And then so to me, all of this is like a long way of saying and going around that, like, I guess I see a research paper like this, right? And this is the very first one that, again, I said at the top of this video, where it's the very first paper that I've seen ever that is like essentially like their two steps. They're taking their statements and their conclusions within this like two steps further than I ever have on this channel, right? Like I've been very clear to like very purposely stay away from like and make this distinct, right? And then they're saying no, it's the same, bro. Like latent space and the geometric and the latent space projection of your brain overall are essentially like the same is what their claim is. And like so I guess to be clear within that, like I'm not supporting their claim within that 100%, right? Like I'm not like, oh, there's a research paper that comes out that they're like stating that, and then it's like two steps ahead of or beyond what I've said within this, so then I should 100% adopt it just on face within that, right? Like I'm not saying that at all. Like I'm still, I don't know this. I don't know if I don't like I don't accept this paper on face just because it's the first paper that I've seen around and stating these concepts overall. This paper gives me a huge amount of places and areas to think about within this, right? Like I honestly didn't think that I would be having these discussions and framing this in these particular ways, like at this particular point. Like, have I reached and thought of these conclusions in this way? Of course, right? The framing and the context and the background that I'm giving you is very specifically my, like, how I have been approaching it and thought of these things on a philosophical level when it comes towards that. And then so very clearly within my philosophical approach to this, I've made in that approach the correlation and the similarity between this latent space and the, I'll call it the human latent space, right? But I've always kept it in the realm of philosophy, right? And then I keep it there, and I theorize on it. I've been very like distinct within exactly how I frame that overall and what the implications of that are. Right? I still don't know. I don't know what the implications of that are overall for anything beyond what it is, right? But like. Yeah, I'm just laying it out exactly there as to exactly what is going on within this research paper. But it's like they're everything that they lay out and their whole entire backing within this is, again, it's they're taking it from a non-philosophical level. It's a pure mathematical approach. And then their pure mathematical approach and then what they're saying leading up to these things are the exact same thing that I've been telling you up front, right? That it's essentially a distillation process at the core that models, the transformer models are essentially utilizing and compressing via distillation strategies. And then when you combine that with global attention and local inductive bias, which is essentially like the algebra combining with, which then creates a geometric projection, and that geometric projection as a latent space. That latent space is then shaped, and everything about the model is then therefore this latent space, right? And then that's the hardest concept of all of this to grasp overall and to understand, right? So memory within the model, the knowledge of the model, a lot of different things. Like the model itself is the latent space, right? It's not the weights that make up the latent space. It's not transformer mechanism. It's the geometric projection, like, and then that geometric projection is what houses, holds, and contains all of this. Like that geometric projection is everything, and you can bolt onto that geometric projection. And I guess that's very specific. Like, so there are some very key elements and important things to highlight and point out within that. So the relationship between model brain likeness score and its downstream task performance. So essentially what they say within this is that creating a more brain-like structure doesn't 100% necessarily correlate to accuracy, an increase in accuracy. That there's correlation but not causation, essentially, would be the best way to frame that. And then beyond that, there's a few other conclusions that they draw. And this is the biggest one to me, right? Model scale is not a master key. And then so just essentially like scaling up the size of the brain is only half of this equation overall, right? And it's not the biggest half of the equation. And then so model scale, it's exactly what we're seeing and what we're running into, right? That there's a minimum threshold that you would want, which around, we'll call it like 250 million parameters. This is known, right? And then that's kind of like the minimum, and then we know that there's a maximum at this point, which like we'll call like maximum effectiveness. Like, so there's a few models that are still coming out in the trillion parameter range, right? But like when you look at those, I'll call it and frame it how I see it. When you look at like the trillion parameter models, like Kimi K2 is like the latest one, right? And that was released like this month. But Kimi is still like not like number one on the benchmarks overall, right? And then and Kimi is the latest, and so there's scale to an extent, but it's above 400 billion. Like this seems to be a very hard cutoff, and like a lot of it is people make the correlation and the distinction to the availability of data, and that's true to that into an extent, but we're just seeing more and more, and like there's now a multitude of models that are proving this out, right? And every single model just happens to fall within this, where we have a lot of models now that have been released at 400 billion parameters, and a lot of models now that have been released at 1 trillion, and those 1 trillion parameters, they're always disappointing. Like, I mean, it every single time, right? And then like it goes into and it just further proves out things exactly like this. And then their last conclusion here again, like brain likeness and accuracy are not identical twins, right? So correlation doesn't equal causation, but like they show correlation within it, but not causation. And then their last thing is able to prove it out via graph-based methods. And then so again, overall, their approach within this is very they're approaching it from the mathematics perspective overall. And then so whether or not you want to agree or disagree with the claims of this paper, like they're not claiming it in the philosophical realm. They're claiming this in the mathematical realm via their examination of 151 transformer-based models, and then again all modalities. And then they show within that, I mean, essentially everything, like a few concepts that I've been talking about from the beginning on this channel as well, right? Which is that like a big part of this and the big step forward within this, like I guess that's the last place within this, is like what are the next steps forward within this are just more attention to the training overall, right? That's the biggest thing, and the biggest impact within it. So reinforcement learning, everything that is involved with that, getting the reinforcement learning better, removing the rewards, right? Like a lot, and like I do see, and I of course keep up with like a lot of the criticisms around like AI and the subject of AI overall, and a lot of people, myself included within that, their biggest knock on these models exactly as they are all around essentially like we'll call like attention and reward, right? And like it is, and I will 100% state that exactly as it is, like attention and reward in the models currently is like not good. Like it's the biggest problem that I see personally within the models. The so Attention is all you need, right? Like before attention, there was questions as to whether or not all of this worked, and then so the question since attention has been would and how would you make all of this work without attention, and then so that was a question up until very recently, right? Like would all of this actually work without attention, because attention is all you need and none of it worked properly like the way that it does prior to attention. So there was no known prior, right? And then now there is, like we know now 100% that like the attention mechanism and the way that it's built isn't necessary to this equation, but it was a 100% necessary stepping stone to get us to the next place, right? And then so to me, like there is a danger 100% in that and this current architecture as it currently is being captured because of all of the so much monetary investment into that, and then because of the fact that the attention mechanism does work as it does, right? There's a chance that it could be utilized and that could be exploited. But to me, like the best and the biggest way to make sure that that doesn't happen is to continue and along with research like this, right, which is understanding the underlying mechanisms of these principles overall, right, and then whether or not you want to take the leap that this research paper does to this extent, it doesn't disprove this extent, right? That there's a geometric space that occurs within AI models, and that's this geometric projection is where the learning and the models live, where the models are, etc. Right? And then within that, and then within understanding those things, and then building out those things, those will be it will obsolete the need for attention, like and make it less performant overall, which is what is will prevent capture, all those things better than anything else overall. Is how I look at this equation. So I'll leave a link to this particular research paper here. Again, the weirdest research paper I've ever come across so far, but a unified geometric space bridging AI models in the brain. And if you like this type of content, please like and subscribe. Thank you very much.